Alright guys, this is Algebra 2, Day 2 of 512. So we're going to pick up where we left off last time. And we're talking about inverses, specifically the graphs of inverses. And, oops, back over here. So we want to take a look at the same thing that we graphed last time with the carbon copy method, where we did the hard pencil and then folded it and then kind of tried to transfer that graphite over to the other side, right? So here's that equation. We're going to have x to this x over 2 to the second power. So we're going to actually go through and find the inverse of that as far as the equation goes. Let me get my camera ready here. We'll change it over to that. So to start, we're going to take the equation of y is equal to x over 2 squared, right? And so to find the inverse, we have to first transpose the x and the y variables, because our inverses are when our inputs and our outputs get flipped around. So x equals y over 2 squared. So now we got to solve for y. So first thing that I do is I square root both sides. So I get rad x equals y over 2. Now whenever I take a square root, I need to make sure that I put a plus or a minus in there. And then I need to get y by itself by adding by multiplying by 2 on both sides. So I get plus or minus 2 rad x equals y. So that's going to be my inverse, right? So I've algebraically found how we do that. And again, not too bad, it just kind of ends up being this fairly basic algebra for us. So if we head back over here, right, what we're going to do now is try and say is the inverse function, all stuff like this. So I'm going to actually hop over to my Desmos camera. There we go. So we're going to graph the original here, which the original was y is equal to x over 2. Here we go, to the second power. And our inverse, we have to do it in two separate equations because it's plus or minus. Y equals positive 2 rad x. And the other one is y equals negative 2 rad x. So if I go here and just make it look prettier by making those both the same color, right? I have my red graph is my original, my blue graph is my inverse. And you can see that, yes, those are reflections over this y is equal to x line. So we have our inverse here. So first of all, is that blue graph, our inverse, is it a function? Well, no, right? Because it's not passing that vertical line test. If I take any vertical lines here, I'm hitting it at more than one point, and our vertical line test says, hey, we can only touch at one point ever for any vertical line on this particular function for it to be a function, right? So we have a non-function here. So how can we fix that? That's our kind of goal here. Well, if I look at my red graph, right? If I limit the domain, which we do by putting in curly brackets, x is bigger than or equal to 0, right? And I look at just this portion, right? If I took the inverse of only this part of my graph, I would only get the top part of my blue graph, right? Because the rest of it, that left-hand side, gives me the bottom part of my inverse, right? Another way to think of it is, well, on our inverse, what's causing problem is this plus or minus part. So what if I just take off that minus part? Now the blue part is a function. But I can't just get rid of that because currently my blue graph is not a inverse of my red graph because it's missing that bottom portion. But if I add that domain restriction, x is bigger than or equal to 0, now it is an inverse. So my blue graph is an inverse of my red graph, and my blue graph is a function. So how we got that is by restricting the domain, by saying, hey, we can still do that, but only if we limit the domain to only this portion here. And then we do get a function for our inverse. Now, you only want to do this if there's a reason for it. The plus or minus 2 rad x is still the inverse of x over 2 raised to the second power. but quite often we're going to want our inverses to be functions because we can do a whole lot more with functions than we can with non-functions. So we can restrict the domain in order to make it stay a function so that we can do more things with it. And that's the kind of rationale behind why we would actually want to be doing this. So let me hop back over here. So go ahead, pause the video, open up Desmos, and try out number 22 on your own. This the same thing we just did, just give it a shot. All right, now that you're back, we're going to go ahead and do that one for ourselves. So that was y is equal to x minus 3 to the second, right? And then if we do the math for the inverses, we get 3 plus or minus rad x. So we'll do plus rad x, and then we'll do 3 minus rad x here. So if we show that, here is our inverse, right? So again, we have it reflexive over that y is equal to x line. Awesome. So once again, if I want to make my blue graph an inverse, I need to get rid of either the top half or the bottom half, right? I technically can do either one. We typically want to go for the positive version, that's just what's going to be the one we care about the vast majority of the time. So if I only want this top part, well, what part of my original graph gives me this blue graph when I do that folding? So think back to when we did the folding last time. What part went where? That's why that was important, is this. So really it's the right-hand side that would reflect over and give me the top part of my blue graph. So I need to restrict my domain here. Now I only want to see it from here and to the right. So that's 3 and greater. So I need to restrict my domain to values of x that are greater than or equal to positive 3. And there, now I have those inverses, right? My right graph is an inverse of my blue graph is an inverse of my red graph, and they are both functions. They both pass that vertical line test. Awesome, that's what we were looking for. All right, let me hop back over here. Oop, wrong camera, there we go. All right, so the last thing that I really want to talk about here is the notation for inverses. Now you're going to see it as being f raised to the -1 power. It does not actually mean raised to the -1 power, right? It's just the notation that we use, okay? You will see it right next to the f if it's an inverse. If it was the function raised to the -1 power, you would see it on the right-hand side of that. So it would be on the outside of the f of x part. But again, you're rarely going to see that just because it gets a little bit confusing. Now this is that same -1 power thing, which means the inverse, which you've seen in the past, particularly when you did trig, so sine, cosine, and tangent. That second feature of sine and cosine and tangent, which is the -1 power thing, that is the inverse. So it does the opposite of sine, it does the opposite of cosine, it does the opposite of tangent. It undoes those things. So those are the inverses for us. Okay, so with that, here is our homework for day 2. We're doing 33 through 39, and I will talk to you guys next time.